Hello, I'm Shannon,
Hello, I'm Jack Bailey, your K-5 math supervisor.
and today we are going to focus on second grade plotting, comparing, and ordering numbers.
All right, I'm excited.
All right, you ready to dive in? Before we dig into the content, we are going to focus on a task. Before I show the task to everybody, go ahead and pause. Once you see the task come up, you are going to complete the task either on your own, with your team, or with your partner, and think about what your instruction would look like for the students to be successful with these tasks. So while you pause, Jack and I are also going to complete this task. Here is the test, the task, which is A through F. Go ahead and pause, and we'll be right back. Welcome back. I think I got all the right answers.
I definitely did.
All right, let's go ahead and dive in to see how we solved the different parts. Before we do that, it would be important to look at the standards that we're going to be focusing on, right?
I mean, I really wanted to show my solution, but okay, let's do this.
Don't worry, you'll have a chance. So here you can see the background knowledge that students will be coming into second grade with from first grade, what they should be able to do by the completion of this unit, which is highlighted in pink here with the second grade expectations, and also what students should be getting into when they get into third grade. So I'm going to ask you to go ahead and pause on this video for just a moment, read through the different grade level expectations, and then come back and think about a connection that you notice between each benchmark. We're also going to pause, and I'm going to put Jack's knowledge to the test and see what he notices. All right, so we're going to see if what you noticed, same thing was what Jack noticed. What did you notice, Jack?
All right, well, thanks for giving me that moment to dive in. So one thing I noticed is that it seems like the main focus of some of these benchmarks is the same for each grade, but it's just that the numbers increase in place value. And of course, that requires students to then have a strong foundation from the previous year in order for us to build on it this year.
Exactly, yes. The primary grades are really setting the foundation for our intermediate grades. If a student has unfinished learning, however, the teacher can easily differentiate to meet the needs of their students by changing the place value expectations. We're still plotting numbers just with a different place value, and then slowly getting into the greater numbers.
Makes sense.
All right, so as promised, we are going to dive into this task. So remember when we were sorting the different ways, we thought about how if it was concrete, how we solved, if it was representational or abstract, how we solved. So Jack, how did you solve A through F?
I pretty much just thought about it, so I guess you would say I did it all abstractly.
Okay, so you use numbers.
I did.
Okay, well, let's take a look to see if we can make some connections to ensure that just because we have that abstract understanding, we want to make sure we give our kids that foundational support they need. We don't want to move too quickly into the abstract portion. So let's take a look at letter A. How did you solve letter A in your task?
So I just listed off the three numbers that I had created.
Okay. So let's look at an example here. Here is a concrete example. That means we have tools out, we're representing what the numbers look like and how great they are or how small they are. What do you notice about the two different representations of concrete?
I know I can see the base 10 pieces, and those I have experiences with, so that makes sense to me. How that connects to the numbers that I could have put down. But those dots there, I'm not sure what those mean. Those look a little bit more challenging to understand.
Yeah, they are. They're called place value discs, and it's a great question. And like you said, they look a little bit more challenging to understand. And so that really means we want to start with those base 10 blocks because They are what's called a proportional model, which means they represent the size of the number shown. So the rod, which is the tens place in the middle, is 10 times greater in size than those units, which are in the ones place. What can you tell about the proportion of the flat?
Okay, yeah, that makes sense. And so the flat would then be 10 times greater than what I see with the rod.
Yep, exactly. So thinking that place value discs are non-proportional, what do you think that means for student understanding?
I mean, I would think that students are going to need to have a strong foundation with base 10 and understanding what's going on with the base 10. I can see that the place value chips allow students to do things more quickly. It looks like they also would allow them to go into larger numbers, but if they don't have that foundation, they would struggle.
Exactly. So how do you think we could build connections with the base 10 blocks and the place value discs? Because really, let's be honest, the place value discs are so much easier to use because they're smaller, they're not as chunky, they're just easier all around on us as the teachers.
Well, I would think at first, anyway, when you first start, you could have students represent the same number with both and lay them side by side so that they can see the comparison of the base 10 pieces to the place value and then, of course, to the abstract.
Right, yeah. So in our example, it is representing the same number. So you can see that there's 400 spots and there's also 4 of the 100 place value discs. So we can talk about how each place value is the same, even though it just is different in proportion or in size. All right, so are we ready to look at the representational stage?
Absolutely. I knew this was going to be exciting.
Okay, so looking at example B that you did in your task, how did you solve that?
So I used a number line on that one.
I thought you said you did all abstract models. A number line is a representational model that connects to the abstract way of thinking. So it's representational because it represents the magnitude of the numbers on the number line. So you can actually see that the numbers are being represented, like 418 is closer to 400 than it would be to 450. So if we look at our example here, we can see that this student thinking placed those numbers in proportion to, or in magnitude on the number line. So what do you think if a student were to show you this number line?
So if a student were to show me that number line, that would mean that they have an understanding of how the numbers are connected, which numbers are closer and farther away from each other, and that would also mean they probably understand the size of the numbers, and I would imagine that they had had some good experiences previously with representing those numbers concretely.
Exactly. We can definitely see the student's progression of learning. And knowing that there's a connection to the numeral representation with the magnitude of numbers means that they're probably ready to move on to more abstract ways of representing numerals. You ready to move on to example C?
Am I? Okay, here we go. I see abstract. That's what I was doing. I was using the abstract method.
Yes, definitely. So experiences like letters C through F often lead themselves to representing numbers abstractly, which is why we want to make sure we give students experiences like that A and B, that concrete and that representational, before we move on to more abstract understanding.
Is it okay to have the expectation that if some of my students aren't ready to just show abstractly, that they can build the number, say, concretely or on the number line, and then try to make that connection to the abstract?
Yeah, I think that's a great idea. By giving our students experiences like this, we are supporting the bridge between the learning through the different models and not expecting everyone to show one way or another. So that's definitely a great idea. So these are just examples of answers that you could have had for C through F, and you can see they are represented abstractly because they're simply showing the numerals along with the symbols to represent the inequality.
Okay, great. My answers look like that, so I do get 2 points for that.
Perfect.
All right.
Numbers on a number line can support student understanding of comparing numbers later on and ordering numbers.
No, not really. I'm still a little uncomfortable with how these number lines are going to help.
It's okay. So many people are, and honestly, I was too at first. So let's look at some different language to support student understanding for plotting numbers on a number line. for this question that's going to pop up, if I was looking for students to plot 458 on a number line, and I asked them to plot with this number line, where do you think they might plot 458?
I mean, I think they'd probably be all over the place, but I bet a lot of kids would be close to the 500 just because they see that 458 and they see the 5 there. So I think they'd be pretty close to that 500.
Yeah, exactly. So I think that our language might have something to do with supporting students with their number lines. So let's look at this task here. How do you think this would support students if we're guiding them to look at the midpoint?
Okay, yeah, I see that question would be really powerful. And if kids are thinking about that, like where is the midpoint between those two ranges on the number line, knowing that where the 450 is, now I can see my students would easily just put the 458 much closer to the 450 than they would to the 500.
Exactly. So we want to make sure that we're precise with our language, and we want to think about what we want to get from our students, what we really want to them to know. If they're looking for the midpoint, then we need to support them with that midpoint language. Later on, once they've had experiences with the midpoint, then I might ask them to determine to plot the number with the 400 and 500 and then see if they can create the midpoint on their own.
Yeah, and they'll probably start creating that in their head then as a strategy.
Absolutely. Given our kids' experiences with plotting numbers, if we ask students to compare two numbers, say 458 and 418, we might get some students in our classrooms that show an example like this with a number line. And we also might get an example like this with an inequality or simply with a sentence.
Yeah, so how do we get the students that are using the number lines to see how their work connects with that inequality statement?
Well, we could definitely ask students how the number line helps them prove their inequality. We could even partner kids up and ask them if they agree, if they disagree, how they can prove that inequality thinking with the number line, and vice versa, how they could prove the number line is correct with the inequality.
Okay, that makes sense.
Yeah, and we have kids at all different stages in their learning, so it's okay to have different representations, but it is important to make those connections between all of those stages. So we have plotted and compared with number lines. We're ready to order numbers on number lines. So when we look at an example like this, what do you notice about the vocabulary when ordering numbers?
Oh, I see ascending and descending order. That makes sense to me, but I gotta be honest, I don't think I used those terms before. Is that something new this year?
Those are definitely new terms with our new BEST standards. So we want to make sure we're using the language least to greatest, but we also want to make sure we are using the language of ascending as well as descending order. If we're using it, our kids will use it as well, and we can say, I want you to put these in descending order or least to greatest, so they're hearing what that descending or the ascending means.
That makes sense.
I know there's going to be a lot that you're going to see on this slide, but what do you remember about what we discussed with the concrete thinking?
Well, first of all, I think that's essential and something that I definitely can't skip over from my students.
Absolutely, and we want to make sure we're making those connections between the base 10 blocks because they're proportional and the place value discs because they are a little bit more abstract to understand. And then we remember we're moving that thinking into our representational thinking, making connections. We can still use the base 10 blocks and place value discs while we're creating number lines to help student understanding. And then lastly, moving into that abstract understanding. And there's those connections to those bridges. Remember, it's okay to go back and forward at the same time throughout the unit.
Yeah, I feel like this is going to give my kids a much deeper understanding of when they're comparing numbers and their ability to back up their thinking, their ability to say, here's why I know this is correct. And that's going to be powerful for them.
Absolutely. Thank you so much. Stay tuned for our next one on rounding.
Thanks, everybody.